Good day everyone. For today's video, I am going to present my performance task for week 5 and 6 in probability and statistics. Without further ado, let's proceed to the instructions for the performance task. First instruction is to form a group of 4 members from your family, relatives, or friends. Make sure that the weight of each member of the group is different from each other. Next is get the weight of each member of the group in kilograms and round off to whole number. Consider this data as elements of the population. For the members or the participants, I chose my dad, my mom, my little sister Faith, and of course me. For the weights, my dad weighed 62 kilograms, my mom 55 kilograms, my little sister 29 kilograms, and me, I weigh 69 kilograms. Next is I'm gonna make a table. This is gonna be our table 1 with 2 columns. For the first column, we're gonna be label it with A, and the second one is B. Column A is where we put the names of the participants, and column B is their weights. So first things first, I'm gonna solve for the population mean, which we will gonna be using later. So this is the formula for the population mean. To solve, just add all the weights, which is 29 plus 55 plus 62 plus 69, and divide it all by 4. So 29 plus 55 plus 62 plus 69 is equal to 215 divided by 4. And we will have the answer 53.7, or you can round it off to 54. Next is we're gonna use this formula. Where this is equals to 4 and the other one is equal to 2. So substituting to the formula, we will get this. And now we're gonna solve. So 4 factorial will be 4 times 3 times 2 factorial over 2 factorial and 2 factorial. 2 factorial because 4 minus 2 is equals 2 and the factorial sign. Okay? And this will be equals to 4 and I forgot. 2 factorial and 2 factorial can be crossed out. So it will be 4 times 3 over 2 times 1. Solving this, we will get the answer 12 over 2 or 6. So there are 6 possible samples of size 2 that can be drawn. Now, let's get to the third instruction. Suppose samples of size 2 are drawn from the population. List all the possible samples and the corresponding means. Here is the table for our possible samples and the mean. First possible sample is 62 and 55, 62 and 69, 62 and 29, 55 and 29, 55 and 69, 29 and 69. Now to solve for the mean, simply add the possible samples. For example, 62 plus 55, then divide it by 2, and it's equals to 58.5. Another is 62 plus 69 divided by 2, and you will get 65.5. Following this process or pattern in solving, you will get these answers. Now, let's get to the fourth instruction, which is construct the sampling distribution of the sample means. So here's the table for our solving. Here in the sample mean is also the same as the means in a previous table. For frequency, it refers to the number of times the value of sample mean appears. So each one of them only appear once, so let's write it all 1. In probability, there are 6 sample mean and they only appear once, so they can be written in fraction as 1/6 or 1/6. So for the total, frequencies all 6 and probability is 6/6 or 1. For the fifth instruction is to solve for the mean and variance of the sampling distribution of the sample means. So here's our table for our solving. Just copy again the sample mean from the previous table. Also the probability, which is 1/6. Or in decimal form, it can be 0.17. To solve for this, I just need to multiply the sample mean with its probability. I'm using decimal form so it can be more easier. So 58.5 times 0.17 is equals to 9.945. Other is 45.5 times 0.17, and we will get the answer 7.735. Following the pattern in solving, and we will have these answers. Next is to add the results, and we will get 54.825. So the mean of the sampling distribution of the mean is 54.825. Last is to compute the variance of the sampling distribution of the sample means. We have this table for our answers. The X means sample mean, which is you can also copy from the previous table. This is the probability, which is equal to 1/6 or 1/6 or 0.17. To get the answer for this, simply just subtract the population mean, which is equal to 54. Following the formula, 58.5 minus 54 is equals to 4.5. Also, 45.5 minus 54 is equals to negative 8.5. Following the pattern, we will get these results. To solve this part, simply just square the difference or square this one. 4.5 squared is equals to 20.25. Negative 8.5 squared is equals to 72.25. 11.5 squared is equals to 132.25. Negative 12 squared is equals to 144. Eight squared is equals to 64. Negative 5 squared is equals to 25. To solve for this part, simply just multiply the results by the corresponding probability. So 20.25 times 0.17 is equals to 3.4425. 72.25 times 0.17 is equals to 12.2825. 132.25 times 0.17 is equals to 22.4825. 144 times 0.17 is equals to 24.48. 64 times 0.17 is equals to 10.88. 25 times 0.17 is equals to 4.25. Lastly is to add all of these, and we will get 77.8175. So the variance of the sampling distribution is 77.8175.